there's about 4 or 5 things that you need to pay attention to. The very first thing you need to see is your equation in slope-intercept form? Bless you.
Thank you. So there's about 4 or 5 things we need to know about 4 or 5.
About 4 or 5.
Is your equation already in slope-intercept form? If the answer to that question was yes, you're good to go. Right? You can keep going on.
Sorry, Miss Lana, I didn't say that. I gotta work on that.
If the answer to that question was no, you need to first put your equation in slope-intercept form. Which again is that y equals mx plus b, where m stands for what? Somebody who said that you need to say it louder and more confident. Slope. And what does b stand for? What does that b stand for?
Y-intercept.
The y-intercept. Okay. So first thing you need to know, is my equation in slope-intercept form? Yes. I'm good to go. I can maneuver through these next few steps. If it's not, you got to get it in slope-intercept form first. Because when graphing lines, you can still graph lines if they're not in slope-intercept form, but I promise you that this is the most simplest way to do it. After you make sure that your equation is in slope-intercept form, you need to identify what your slope is and identify what your y-intercept is. Okay? Once you kind of do that and pull out that information, you can start to graph things. So the very first thing that you are going to plot or graph is your y-intercept. That needs to be done first. Why do you think we graph it first? What does the y-intercept represent? What does the y-intercept represent? It does not represent crickets. What does your y-intercept? I really like what Kaylee's doing, going back in her notes to figure it out. Oh, she's caught on to her classmates. Her classmates are starting to do the same thing. What does your y-intercept represent? Julia?
The point at which your line crosses the y.
Okay, so yes, it is the point at which your line crosses the y-axis. It also represents your starting point. Okay, so not only does it represent how it crosses the y-axis, it represents where you're going to start from when you're graphing your other points or plotting your other points. Now, even though it's your starting point, does that mean that you can't plot points below it? If this is your starting point, does that mean that you can't plot points below this? No, it doesn't mean that, right? Because lines go on forever and ever in both directions, right? But it's just kind of where you begin to graph your line, okay? You need some place to start to put all your other points. So yeah, exactly correct. It doesn't necessarily mean there's not points below it.
Like a number line, as long as there's an endless amount of numbers at the end.
Correct, right? Because it doesn't, does a number line technically start at 0? Well, no, because there's not really a starting point. But we always kind of go from 0 and count in either direction. It's the same here. You always want to start at your y-intercept and kind of use your slope to go in both directions. So after you've plotted your y-intercept, you're going to use your slope or your rate of change to plot additional points on your graph to create that linear function. You need to make sure that you include points on both sides of your y-intercept. After you do that, you need to label your line. Labeling your line is super useful when we start getting into systems and we have more than one line. We want to make sure we know which line represents what. We also want to put arrows on either side to show that that line does continue to go on forever and ever. After you finish writing this down, you can go ahead and do example number 1 and glue in a coordinate plane, and that signifies to me that you're ready to move on. Well, let's talk about this equation that we're going to graph. First thing I want to ask you is this equation written in slope-intercept form?
Yes.
Yes? How do you know?
Because the y divided by itself.
The y is by itself when it's equal to something, right? So I have y equals 4x. I have all the information that I need. I have a y-intercept, and I have a slope. Let's talk about its slope first. What is the slope of this line? 4. Positive 4 or negative 4?
Because it's behind.
Positive 4 or negative 4?
Oh,
Positive 4, right? Because the 4 right here is the coefficient of my x, and that tells me that it's my slope and it's positive. Now, I know that slope is change of y, over change of x. Okay, I know that slope is the change of y over the change of x. How can I write the number 4 as a fraction to where I can see the change of y over the change of x? How do you write 4 as a fraction?
4 over 1.
4 over 1. Perfect. I want to make sure that I do write that slope as a fraction, because I can now very easily see that the change of my y values is 4, and the change of my x values is 1. I can very clearly see that change. Make sense? So if you have a whole number, should you change it to a fraction? Yes. Yes. Because you can see the change of y over the change of x. If you don't, you're just going to get confused. What's the y-intercept of this? What's the y-intercept of this equation? Think, y equals mx plus b, where b is our y-intercept. What's the y-intercept of this equation?
4?
That's our slope. 4 is our slope. X is a variable. Finley? 0.
Because there's not.
If I add 0 to this, am I going to change the value of my equation?
No.
No. So if I had a plus 0, am I still okay? So what's my y-intercept?
0.
0. So if my y-intercept is 0, where on my y-axis am I going to plot that? 0, 0. Okay, so I'm going to go ahead and plot that at 0, 0. Smack dab in the middle.
Why would you plot a fraction?
Okay. We're going to get to that here in 1 second, okay? So I've started at 0, 0. So is this equation proportional?
No.
Yes. Why is this equation proportional? Why is this equation proportional? Huh?
Because it's not non-proportional.
That doesn't tell me why it's proportional, but it starts where? It starts at 0. Correct, Matthew? It starts at 0, so I know it's proportional. So, now I've got to use my slope, right? Because I've done step 1 and I've done step 2. Now I have to use my slope or my rate of change to plot additional points on the graph. So, let's go back to this. What is the change of my y values? What's the change of my y values? 4. What's the change of my x values?
0.
1. Let me ask you again. What's the change of my y values?
4.
And what's the change of my x values?
1.
So if this is a positive slope, my line should kind of quote-unquote point in what direction? Right or left? To the right. It's going to point towards the right. So that means as one value increases, the other value increases. We're talking about positive slopes. As one value increases, the other increases. Can it still work the other way, that if one value decreases, the other value decreases? Yes, right? Because 2 negatives make a perfect. Okay, so I'm going to start here. And I know that the change of my y values is 4. So I'm going to increase by 4 on my y-axis. 1, 2, 3, 4. Am I done though? I've got to go over 1. Am I increasing or decreasing? I'm increasing still. I can plot a point. Now, from here, can I increase 4 and increase 1 again? Yes. 1, 2, 3, 4. Increase 4. Increase 1 with the x's. So now let's go back to 0. So Garrett, let me ask you a question. I'm going to go down, I'm going to decrease by 4. 1, 2, 3, 4. So Garrett, If this is a positive slope and I decreased by 4, do I decrease by 1 on my x or do I increase by 1 on my x? I decrease as well. Perfect. Because remember, positive slopes, whatever value increases, the other value increases, or if the value decreases, the other value also decreases. So now I can go, beautiful, I can go 1, 2, 3, 4 more, decreasing,
2 more.
decreasing again
Oh.
by 1. Do I have enough points on this so I can draw a straight line pretty accurately?
Yeah.
Yeah.
Okay. Would it be completely straight?
If I had a ruler, yes. But I don't have a ruler, so we're doing the best I can. Notice how I also have an arrow and an arrow to show that my line goes forever and ever in either direction. And now I need to label my line as well. So y equals 4x. I labeled it with my original equation. So now, if I use my similar triangles, right? Oh, this is not very straight. Shoot. But if I used my similar triangles, this would be an 8 over 2, and this would be a 4 over 1. Are they equivalent?
Yes.
Yes, so I had a consistent slope. Yes, sir?
Oh, I didn't see it because you didn't go in the middle. Wait, is that two? Is that two triangles?
Yes, 1 triangle, 2 triangle.
Okay, well, it was confusing because I was just looking at the purple and it looked like a messed up block.
Oh, no. Here, let me.
Yeah, there.
Does that help?
Yeah.
And what if I did the other one another color? Would that help? Does that help? A little bit? Okay. Huh? Y equals 4x. My original equation. I graphed it, or I labeled it with my original equation. So have I successfully graphed my line?
Yeah.
I sure have.
Don't you have to make right triangles for the negative?
I don't have to. Okay, so we did that right triangle activity to prove why slope worked. I don't need to do that on here unless you just want to make sure. Okay? All right, let's do another example.
Oh, my head's tired. My body's tired. My legs are tired. I'm tired.
So,
All right, so let's look at this example. Y equals negative 4x plus 7.
we don't have our slope. We need to make it into. Oh wait.
All right, so with this equation, y equals negative 4x plus 7. What is the slope of this line?
Negative.
Negative 4. How can I write negative 4 as a fraction?
Negative 4.
Negative 4 over 1.
Negative 4 over 1. And what's the y-intercept of this equation? Positive or negative? Positive. So I identified my slope, changed it into a fraction so that I can easily see it. Now, what if my slope was already a fraction? Am I good to go?
Yes.
Oh, yeah. I really like to graph lines. Like I really do.
I don't.
Okay. Where am I going to start? What's the first point, Jacob, I'm going to plot?
Positive or negative 4.
Ooh, what do I plot first?
0.
Positive 7
Positive 7.
on the y-axis.
On the y-axis, I plot my y-intercept first.
Oh, I thought it was always.
It's only always there if it's proportional. In this case, it's not,
Oh.
right? Because y equals mx plus b, where b is our y-intercept, right? So we're going to plot positive 7 on the y-axis. What if my y-intercept was negative 7?
You go to negative
I'd go to the negative 7. But since it's positive, 2, 3, 4, 5, 6, 7, I'm going to start my graph right there
And would you go to negative
at
6?
positive 7. Hang tight. I know you're getting really excited. Hang tight. Since I have a negative slope, which direction when I'm finished should my line kind of point? What's that way?
Towards 7.
Right or left?
Left.
Right, left. It's going to point towards the left. So, I have a slope of a negative 4. Negative 4 over 1. Tell me what our kind of definition was for negative slope. What was that definition we came up with for negative slope on Tuesday? Connor?
When one is increasing, the other is decreasing.
When one value increases, the other value decreases. Perfect. So let's say I want to decrease by 4, right? Because change of y was 4. Do you agree?
Yes.
So I'm going to decrease by 4, starting here at my y-intercept. 1, 2, 3, 4. If I decreased by 4,
Decrease by
if I decreased by 4 and I have a negative slope, do I increase by 1 or decrease by 1? I increase
Let's go.
and plot a point. Because remember, negative slope, Nathaniel, up here, negative slope is when one value increases, the other value decreases. Or if one value decreases, the other value increases. So now here I am at this point. Could I decrease by 4 again? 1, 2, 3, 4. And then could I increase by 1?
Yes.
I thought it was increase by 2. Or is that how
Why
it
would you
was?
do it 2 times though?
Oh, you counted from the dot.
I counted from this next dot.
Oh.
So even though I'm starting at my y-intercept, when I plot additional points, I'm going to kind of use my slope from the point I just plotted. Okay? So if I just plotted this point,
You go down by 4.
1, 2, 3, 4, decrease by 4, increase by 1. Decrease by 4, increase by 1.
Why do you do
Now, could I increase by 4,
And then
decrease by 1? Beautiful. It's going to kind of be up there at the top. You've got to think of this not as going up and over. Think of it as, okay, if I have a negative slope, I'm going to increase on my y-axis by my change of y. If I increased with my y, I need to decrease with my x. If I decreased with my y, I need to increase with my x. You've got to have that concept of, okay, what am I doing with a negative slope? What am I doing with a positive slope? Yes, sir?
It's so confusing because since we just did a positive before this, I thought we were, when we started doing this, when it was a negative, I thought we'd do pretty much the same thing.
I mean, you're doing the same types
But
of
just the
things.
opposite way.
So, does my line kind of point to the left?
Yes.
Yeah, so I'm good. So, do I need to label this?
Good.
Yes, I do need to label this. Right, Garrett? And I'm going to label it with that original equation. And I also made sure to put arrows to show that this line goes on and on forever and ever and ever and ever and ever. How many of you guys think you're in the starting process to kind of understand? Okay?
It makes a lot of sense.
All right, so I've got 2 more examples here.
I'm a real genius.
Guess you'll have to wait and find out.
I don't.
Alright, so I've got example 3 and example 4.
Besides, if we have fractions, we can't be absolutely exact.
You can if it's in your slope. So what do you notice about the slopes of these? They're not integers, are they? No, they're fractions, right? So if our slope is already a fraction, doesn't that already kind of give us our slope? Don't we already know what the change of y over the change of x is? Yes, it's already given to us in a fraction. We already know what that is. We don't have to take an integer and change it into a fraction. So, what is the slope of example number 3? 1/2. So, what is for this example, what is the change of y values? Whoa, we're looking at slope right now. Because I know that slope. Again, slope is change of y
I was guessing the y.
over change of x. What is the change of y for example 3? 1. What is the change of x? 2. What is the y-intercept? Negative 2.
I thought
This
that's what you were
is starting to make a lot more sense.
So just to recap. Just to recap, on example 3, we pulled out the slope of 1/2. And we knew that that slope means that there's a change of y of 1, and there's a change of x of 2. We saw that our y-intercept was a negative 2. So there we go, good to go. Let's look at example 4. What is the slope of example 4? Negative 3 over 2, or negative 3/2. So what's the change of y values? What's the change of y values? 3.
Negative 3.
3 or negative 3. We'll take a look at what that looks like. And what's the change of x values? 2 or negative 2. What's the y-intercept? 5. So now that we have identified our slopes and our y-intercepts for each equation, do we have all the information we need to graph?
Yeah.
Yes. So let's start with example 3. Jacob, where am I going to start?
You're going to start at 1. You're going to go up.
Where am I going to start? I'm not going to start at 1. Garrett? Where am I going to start? For example 3, where do I start? Summer? Negative 2 on what axis?
I thought we always start.
Y-axis. Your first point that you plot on your graph is always your y-intercept.
I thought it was always the same.
No, you use your slope after your y-intercept is done. Okay.
Oh, we just did that on once.
Is this a positive slope or negative slope?
Positive.
Positive. So if the y-intercept increases, the x values also increase. And if the y value decreases, the x values also decrease. Sweet. So I'm increasing by 1. I'm increasing by 1. Change of y over the change of x. I'm increasing by 1 on my y values. So now I need to increase by 2 on my x. Yes, sir. Yes. Increase by 1 my y values. My y values increase by 1. My x value Also increased by 2. So here I am. I'm going to go from this point. Could I increase by 1 on my y? And then increase by 2 on my x?
Yeah. So that means you report me right on 4.
Okay. Right on 4. Starting from this point, could I increase by 1 on my y?
Yeah.
And then increase by 1 on my x?
Yeah.
I mean 2 on my x?
Yes.
Yes. Woo! Okay, I've got a lot of points in that direction. I need points on the other side of the y-intercept. So I'm going to go back to my y-intercept.
Decrease by 1.
Decrease by 1,
Decrease
and then
by 2.
decrease by 2. Because 2 negatives make a positive. Here I am at this point again. Decrease by 1,
Decrease by 2.
decrease by 2. Decrease by 1, decrease by 2. Do I have enough lines or points so I can draw my line? Yes.
Maybe.
So, Kaylee, I'm going to come back to what you said. Miss Lyons, we can't be accurate if we have a fraction. Do you change your mind now?
Yes.
What makes you change your mind on that? Huh? We do have a straight line, but what does that slope tell us? Change of y over the change of x. If it's already written as a fraction for us, we're fine. Now, if our y-intercept was a fraction or a decimal, we'd have to do a little estimating. Okay. Let's look at example 4. Are we starting to get it, some of us?
3.
All right, let's look at example 4. Cameron, I always start with my y-intercept. Do you agree? Okay, so on this problem, Cameron, what is my y-intercept? 5. So I'm going to go to 5 on my y-axis. Cameron, what's my slope of this equation? Negative 3/2. So I have a change of y of 3, change of x of 2. Do you agree? And do you also agree that if it's a negative slope, as one value increases, the other value decreases? Okay, so we're going to start here at this point. If I increase by 3, I need to decrease by 2 since it's a negative slope. Everybody with me?
Wait. I thought it's a negative, so we go down.
Oh, we're about to do that, but I increased and then decreased. I'm still doing the same thing. Because I increased one value and decreased the other. So if I wanted to go down, I'm decreasing by 3, so now I can increase by 2. It works the same way. As long as if one increases, the other has to decrease. And if one decreases, the other has to increase. Okay?
I thought if one increases, it has to increase again.
That's if it's positive. This is a negative slope.
Okay.
Positive and negative slopes are different. So now here I am at this point. Decrease 3, increase 2. Decrease 3, increase 2. Okay? It might be easy for some. Some might have some difficult, but I'm glad that you found it simple. I'm glad. So now I connected all my points, and I drew arrows to show that it goes on forever and ever. What's the only other thing I need to do? Label it.
Will you get points
I'll put it back.
for not labeling it?
Yep.
No, ma'am. Wait.
So you have 2 extra graphs. Pause. You have 2 extra graphs. I want you to graph 2 problems tonight for me. 2 problems in your notebooks with those graphs. You should have 2. So the examples that you need to graph. I want you to do these 2 tonight for me for homework. We're going to go over these first thing tomorrow, so you need to have them ready. And these ones you're going to have to put in slope-intercept form. After you have those written down, you can Pack up, put your chairs up, and head to lunch. You don't have these written down. I know you don't. Write them down. 2x, yep. Negative 2y equals 2x plus 4. 4 plus 8x equals 2y minus 2. When you're finished, you may go ahead and pack